Hello, everybody, and welcome to episode 62 of I Wish You Were Dead, a podcast about things that used to be alive. My name is Mike, and that is Gavin. And apparently, we both have next week off. This is good news.
It sure is, although I don't know that for sure yet. Um, so my wonderful fiance basically surprised me for Valentine's Day with some tickets to a comedy show of a comedian who I've heard of, and I thought she was funny. She was on a podcast that I enjoy, and was like, "Oh, that person's funny." And then
Does she have a name?
so the reason why I haven't said it is because I don't know how to pronounce her last name. Let me actually look. Fortune Feimster. I couldn't remember if it was like Feimeister or something like that, but Fortune Feimster.
Mhm.
So she is performing in a town nearby, where I live. And at this point, I thought, well, we both thought that I would be at a different project other than the one that I'm still at in the desert. I was told it'd be starting in like late January, but sometimes with this line of work, timelines get pushed around and stuff. So, it's not that I didn't see this coming, but I guess I probably should have been clearer with that to my wonderful fiance. So she surprised me for Valentine's Day, and it was like, well, if you're going to be down in the desert, uh, you know, pick who I get to go with. I guess Happy Valentine's Day. Because she wasn't gonna not go because I wouldn't be there. She was still gonna go.
That wasn't going to stop her.
No. So then I just asked my boss. Was like, hey, so are we going back to like a rotation where it's like a couple people on and then somebody gets a week off? She was like, yeah, we're actually starting that this week. I was like, cool. Can my off week be next week? And she was like, I mean, I'm making the schedule today, so probably. So as far as I know, I have next week off, but I don't know that for sure.
Well, congratulations. This has been a scheduled winter break. Next week has been a scheduled winter break for me for months at this point. So
Cool.
I've known that it's nice to have set schedules in advance. I guess
Yeah.
there's some inflexibility with that, but it is nice to know kind of when things are.
Yeah, and I always forget that high school has a break then because college doesn't. College just has spring break in March. And so I always forget that like winter break is a thing, at least in most schools in New York.
Yeah, it's kind of nice. I mean, the one big problem is that March just takes forever because there's
Yeah.
nothing going on in March. But
There's St.
you get
Patrick's Day
there is St. Patrick's Day. You don't
and
get day off for that.
sometimes Easter.
Sometimes you don't get days off for either of those, but it is definitely nice being able to have the breaks both in February and in April.
Yeah, definitely.
All right, so Gavin, you want to quickly talk about give a little preview of what we're talking about today?
Absolutely. So today we're going to be talking about a little thing that you may have heard of if you've ever seen a little indie movie. Maybe you've heard of it called Jurassic Park. We're going to be talking about a piece
Did we ever
of
discuss that?
maybe once or twice. But we're going to be talking about something featured in the movie Jurassic Park, which is Amber, the thing that they supposedly got dinosaur DNA from mosquitoes inside of. We'll talk about it. But we're going to be talking about Amber, what it is, how it forms, some of the cool paleontology things, and maybe some of the not so cool paleontology things. But before we get into that, I have a quick little update on something we've talked about the last couple episodes. Which would be the Mill Canyon Trackway site in Utah that we've sort of talked about a couple of times. I think that in the previous 2 episodes, not an update as long as the last couple of episodes, but more or less, things I think are tentatively getting a little better. I did reach out to some people to see if they would be willing to come onto the podcast. A couple of them I reached out to just said that they don't really have time. They're people with lives. I get it. But also a couple people they reached out to didn't say this directly, but I've heard from people that some paleontologists don't kind of want to talk about it publicly because because it's the Bureau of Land Management, the BLM. They control the permitting for a lot of field work in that area, and so they kind of don't want to talk about it publicly because they can. Granted, this would be a bad thing for a federal employee to do, but everybody has their own biases and agendas. So they just didn't want to take that risk, and I understand that. I get that. So
Yeah, as frustrating as it is,
Right. So
you gotta
we
eat.
are,
Yeah.
yeah. So we are going to try to have somebody who has some affiliation with the site on the podcast soonish. Probably not next week. But so that is a goal. Whether that ends up happening or not, I hope it does. But I just wanted to put that back on everybody's radar. That is still a thing that exists. I know our collective attention span is very small, myself included. So. Uh, so this is still a thing that is happening, and that is a problem, but tentatively getting better. Maybe we'll talk about it more soon. So
I would very much enjoy if we had a chance to talk with it, especially somebody who was boots on the ground, if that was ever possible.
yeah, definitely, or maybe even just like a journalist from like Moab or even like Salt Lake that is familiar with it and
Hmm.
that kind of thing. So anyway, from that, Mike, do you have a today in history? Because
I do.
I have a really quick one
Well,
after.
go ahead
So
and do
go ahead.
your real quick one. I also have a very quick one.
Okay, cool.
That is not gonna be too much to talk about. But go ahead. What do you got?
Yeah, not even really a today in history, but this past weekend on the 12th was Darwin Day, named after
Oh, really?
everybody's favorite evolution, like hero, I guess, is how people sort of see him. Evolutionary theorist Charles Darwin. He has a holiday on February 12th every year. I believe that's his birthday, if I remember correctly. So happy
Okay.
belated birthday to Chuck.
Okay.
That's it. That's it.
That's
That's
all
all
you
I got.
got?
Yep.
So, speaking of heroes, this is a great transition. In 1991, so, we got the Olympics going on right now. This was not an Olympic year, but at the female figure skating championships,
Oh
they were won by
boy.
none other than Tanya Harding
Oh
in
boy.
1991.
Oh no. Oh
This
no.
is several years before she became famous for that other thing. But yeah, Tanya Harding, winning championships out here in 1991.
See, I know her. Before I knew who she actually was, she was on some uh America's Funniest Home Video-esque show on True TV. I don't even remember what it was called, but it was like vaguely famous people commenting on viral videos on the internet, and she was one of them.
Oh,
I had no
jeez.
idea what she
I'm
was
stunned
famous
they let
for.
her do that.
I have no idea what she was famous for. Absolutely no idea. Until like a couple of years later. And like when I watched it, I was like, I don't know, like a mid-teens probably. And then I actually learned like what she was famous for, and I was like, oh no.
Yeah, if you don't know what you say, and like it's not like it's that bad, but
No, but
yeah, like go look it
especially
up. It'll
especially
take
in
us a
terms of
hot minute
things
to
we're going to be
explain it
talking
here.
about today.
Yeah,
Yeah.
it'll take us a hot minute to explain it here. So just go look up Tanya Harding, and then like you'll understand. When I giggled a little bit when I said hero. Um, and with that, I think we are ready to actually get to our main topic of the day for real. So amber is what we're talking about. Something that, like trees and sugar and like freezing things in time and like I don't know, it's got like that cool orangey color. Um, and that's all I got. So go ahead.
I mean that is mostly correct. So Amber, in my notes right here, it literally says obligatory Jurassic Park mention. Um, Amber, as I mentioned, is the substance. I was going to call it a mineral, but as I learned, that's not technically true. Um, it is a trace fossil, similar to things like footprints, or I guess a better analogy would be coprolites, which we've talked about, which would be fossil poop. Um, and so amber is essentially just a chunk of fossilized tree resin. If you notice from Jurassic Park, the line that they say is the insect will land on a tree and get stuck in the sap, which is like sort of kind of true. If you actually look up what the difference between resin and sap is, it's mostly a consistency thing. But I don't think that there's like a hard and fast sort of rule. Um,
Okay.
Basically, tree ooze, more or less. Um, and so the whole premise of Jurassic Park was way back in the day. A mosquito bit a dinosaur and sucked its blood, then landed on a tree, got stuck in some of the resin, which then turned into amber. And then scientists were able to take out dinosaur DNA from the blood that the mosquito had drank from that dinosaur. That is the whole premise of Jurassic Park. Congratulations. I've spoiled part of a movie from 20 years ago, almost 30 years ago.
that we have discussed before on this episode.
We sure have. And so amber is particularly famous within paleontology for preserving absolutely beautiful fossils of
Now, why is that?
so the big thing is that you get a 3D, in some cases completely unaltered, like view of something. If particularly of arthropods, mostly insects in particular.
Hmm.
But when they're preserved in rock, that rock has been compressed, so you mostly only get like a 2D perspective of it. Because insects don't tend to be particularly hardy animals, uh, so they get smushed, and you only get to see the top and or bottom of the insect at a time. With amber, you can move it around in 3D. You can see all parts of it, presuming that all of the insect stayed in the amber,
Hmm.
and uh, they're just exceptionally well preserved because it's basically putting it in a little ball, a little see-through ball for scientists to come look at later. And uh, amber itself, though, doesn't have to have fossils in it. Doesn't have to have. They're called inclusions when there are things inside the amber. That is not like a prerequisite for being amber. The vast majority of amber is just that chunk of tree resin that is fossilized.
I do have a question about how, as far as usefulness goes, like I can
Mm-hmm.
imagine, looking at, say a mosquito stuck in amber or an arthropod or anything else, and you can look at it and it's somewhat translucent, and you can actually look into
Mm-hmm.
the amber and you can see the species. I'm wondering how useful it is though, besides just like looking at the thing, because I would think that it's one of those things that's kind of hard to like actually break apart and actually get to the preserved specimen.
So these days, we have all sorts of fancy technology that
Hmm.
lets you sort of like CT scan it and get a much better picture. Because not all amber is the super pretty, very translucent sort of thing that you see in Jurassic Park.
Right.
Very, very rarely does it look like that. Most of that comes from one particular area, which we'll talk about. Uh, but yeah, it is. You can do all sorts of fancy things because things like CT scans or other kinds of scanning technologies. The amber will be a different density than the whatever is included in it. So if you scan it from multiple different angles, you can sort of uh, get a 3D picture that way of whatever's stuck inside the amber, even if it's like the amber itself is opaque and you can't actually look at it, with your eyes.
Hmm.
So it is mostly useful for just looking at stuff. That's true. But looking at stuff in a way that no other type of fossil really lets you do. So, for example, I believe there's a very large group of like flies. I think arthropods and invertebrates in general are not really my thing, so I don't know how true that it is that it's flies per se, but some group of insects often caught in amber are identified today, and like different species are identified today by looking at their genitals,
Awesome.
right? So uh, if it's a 2D fossil, that is much harder. Whereas if it's a completely preserved, 3D specimen in amber, if you know what fly genitals happen to look like, you can sure find them.
Okay. So it sounds like there's at least a little nugget of truth to what Jurassic Park was doing, and I think I know where that kind of goes astray. But the basic idea of specimen being caught in amber is used to preserve X, Y, and Z qualities. That basic premise is correct, even though I think I actually might know where Jurassic Park kind of stretches that too far.
I mean, it stretches it really far in a couple of ways, but yeah.
Okay.
Um, so you can't, to my knowledge, really get DNA, even if you just like, if you caught a mosquito that had literally just bitten somebody, if you like try and get the blood, like it eats that blood, just
Really?
like it. Well, yeah, that's why mosquitoes do it. You know,
Hmm.
they
I
don't
thought that
just
you
do it for no reason.
I thought that you wouldn't even be able to get like any kind of DNA at all out of something that's just that old. Like DNA just doesn't
Well,
last
I
that
mean
long.
that as well, but I was just sort of getting to the point where it's like even a mosquito that has just bitten somebody, you probably can't get that person's DNA from them because they have like digestive enzymes and stuff. So it's like from step one, it just doesn't work. And then yeah, step two,
Gotcha.
there's been multiple studies. There was one in 1999 that like suggested that amber could preserve DNA for like up to 100 million years, and then very quickly, many people were like, I don't think so. And so there was a follow up. There were several follow up studies at the time, but a very detailed one in 2013 that basically suggested that they found some not quite fully formed amber, so it is tree sap, but wasn't fully fossilized yet, with an insect inside of it. That's called copal when it's not fully fossilized yet. And so they
Hmm.
tried to get DNA from that. So it was only like 10,000 or so years old, and they couldn't even get DNA from that. So um, I'm not saying it's completely impossible, but it is very close to completely impossible.
Understood.
But that being said, amber is also useful for a lot of other things. Amber is very culturally important in places where it occurs. It has been used for thousands and thousands of years in things like jewelry, pottery, traditional medicines, all sorts of different things. So it means a lot to various, different cultures, particularly where large outcrops of amber are found. Um, so it's not just useful for its fossils, it's also very decorative and also very just like culturally important to different groups of people.
All right.
So that is broadly what amber is. And I mentioned earlier that amber is not a mineral, and a little bit of geology sort of sneaking in here. Um, so to be a mineral, you basically need to be abiotic. You need to be, a solid, and also have a regular chemical structure. And amber only meets one of those. It's a solid, but it is biotic. It is made by life. And it also doesn't really have a set chemical formula. Different kinds of trees make different kinds of resin, which then turns into different kinds of amber. They're all chemically very, very different, typically. Um, so it's a little complicated. It seems very minerally, and it seems like it fits at like a rock and mineral show, but it's technically not a mineral. Even though even things like ice are. Ice is the one that when somebody told me ice is a mineral, I was like, that whole
Is it
meme
really?
where yeah, it is. But that whole meme where it's like the guy with like angry face with his arms crossed, and then the next frame is him just throwing his hands up. He's like, I guess.
Okay.
That was me when I learned that ice is a mineral. I'm like, I guess it is, but I don't like it. Um,
Yeah, I'm not sure I like that one either, but I'll defer to you, I guess.
yeah. And so there are different ways to classify amber, but not a good. Like if you go to the Wikipedia page, there is like a classification system that they break down. I don't think it really makes sense because I think it said there were 5 classes and then within those some subclasses, and it's like the different classes are differentiated in different ways. So it's not like, you know, class 1 is all has this kind of chemical compound. All of class 2 has this other kind of compound. Like it's more like class A has compound A. Class B has this color and texture. So the different classes are not necessarily based on the same thing, or sometimes based off of what plant is from, which is very hard to tell. Plants, as I've said several times on this show, uh, are aliens. I don't understand them at all, uh, for many reasons. And this one's actually kind of believable, where it's like, even though plants might not be that closely related, sometimes they can make very, very similar resins, which then turn into very, very similar ambers. So it's like, even if you do like a chemical test of the amber, it can be really hard to figure out what plant that's from, especially if you don't even have those plants around anymore. So there are ways to classify amber. Don't worry yourself about it.
We will not be doing that here today.
And so talk about a little bit of the history of amber. So Amber, like I said, comes from plants, mostly trees. I think it's probably technically possible to get it from non-woody plants, but I think that's quite rare. Um, so the earliest known amber comes from the Carboniferous period, found in Illinois. So this was from around 320 million years ago. And if you know anything about the Carboniferous period, that kind of makes sense. That's the first time that we had real large forests of any significant amount. There were some around before the Carboniferous, but they were not very extensive. During the Carboniferous, almost the entire planet was covered in forest. So if there was a time for the first amber to show up, this makes sense.
Mm-hmm.
However, this amber didn't really have any inclusions in it, really. No cool insects or other things trapped inside of it to really find. Although I did find this part really weird. So, like I said, sometimes it's almost impossible to figure out what kind of plant made the amber, but you can generally tell broadly what group the plant fell into, whether it was a gymnosperm, which would be things like your conifers, pine trees, things like that today, whether it's an angiosperm, which is basically every other kind of plant around today. You can tell more or less the large scale group that the plant is in. And so this amber appears to be very, very similar to angiosperms, which is real weird because they had not evolved yet and would not really evolve for over 100 million years. So yeah, so that's a real head scratcher. Most people, I think the general consensus was that it's just a weird convergent thing. It's just a good compound to make resin out of, I guess. Weird.
Mm-hmm.
I find that more believable than we're just missing 100 million years of angiosperms for some reason. I find that way less believable.
Without knowing what I'm talking about, I think I agree with you.
Well, and we will do a plants episode, some kind of plant episode eventually. We'll have a guest on for that because I have no idea really what I'm talking about. But angiosperms, when I say if you think of a plant, you're thinking of an angiosperm, that's not an exaggeration. With the exception of mosses, ferns, and conifers, every single plant that you could think of really is an angiosperm. So it's
what about a carrot?
Yes.
Okay.
Yep.
That's the one I was thinking of. I don't know why, but that's where I went.
But yeah, so if a group that big and ecologically important had evolved that much earlier than we thought, that would shake up a lot of things as how we understand plant evolution. So, simplest answer is often the best. Or I guess the answer with the least exceptions is often the best, which is the actual definition of Occam's razor. Anywho,
correct. Moving on.
So the earliest amber with an arthropod inclusion, so this would be arthropods, your things similar to insects, things like your crustaceans as well. So the earliest one of those trapped in amber was in the late Triassic, so moving up quite a bit to around 230 million years, so almost 100 million years after that, after the first amber that we know of. And it wasn't really all that significant. I think it was a partial one, which was still a new species because it's insects from the Triassic are very hard to come by. So chances are it's something new. And that's generally the case with amber, where it's insects. We know a lot about insect evolution just because of how many there are. So it's just by statistics, a bunch of them are going to get preserved.
Right.
But if you find something in amber, chances are real good it's going to be a new species. Sometimes an entirely new large group that's we know it's some kind of insect. We no idea anything else about it and never seen one before. That happens a lot with amber. So
okay.
Amber really starts to become much more common in the Cretaceous and more recent. So particularly the middle Cretaceous, I'd say somewhere around 120 or so million years and more recent. And that is hypothesized to be because of insects. So insects had been around for quite a while before this, but around this time is when the first like really significant tree boring group, similar to, if you live in the northeast of the United States, you probably have heard of the emerald ash borer. It's a type of insect that I think is native to Asia, somewhere in Asia, that burrows into ash trees and kills them, more or less. And so when an insect bores into a tree, they will produce their resin as sort of a defense mechanism to try and trap or kill or otherwise get rid of these insects that are attacking them. So once insects figured out how to attack trees were like, okay, I guess I need a defense now. So that's hypothesized. Again, really hard to establish that link for sure, but it seems solid to me as someone who doesn't know much about amber.
Okay.
And so amber has been found pretty much all over the world, but if you hear about amber in regards to fossils, you pretty much will hear about it from one of 4 spots. So we'll talk about them in a little bit of detail here. One we will talk about in much detail.
Is there a reason why just these 4? Like, I know you haven't said what the spots are yet. Maybe the 4 spots cover like 70% of the planet, but like,
no.
Okay, like why?
No,
why these 4
it just
spots?
sort of happens to be the right time and place. Like I said, during the Carboniferous, lots and lots of trees around. During the Cretaceous period, there's lots of trees around. So 2 of these 4 are from the Cretaceous period, and then one is from the Eocene period, or Eocene epoch, which also had, pretty much global rainforests, lots of trees. And then the other of the 4 comes from the late Oligocene, so around 25 million years ago. And again, around that time, it's pretty equatorial. Even today, it's pretty equatorial. So lots of rainforesty stuff. So it's just, there was a big forest here for a long time, trapped lots of bugs, and happened to be uplifted, and eroded so that the amber is just sort of falling out while humans are here. And that's really the case with most fossils as well. Realistically, it's all just kind of random chance, which is annoying as a scientist, but it is what it is.
Right.
So the first of the 4, so the oldest of the 4, like timeline wise, would be Lebanese amber, found in Lebanon, a country in sort of central Western Asia. And it comes from the early Cretaceous, so around 130, 125-ish million years ago. And this is really important because, A, it's just really big. There's quite a lot of it, found pretty much all over the country and a little bit in surrounding countries. But this time period is really important, again, going back to our evolution of plants, because this preserves a time when before angiosperms, they were around, but not really as dominant as they are today. And so a big hypothesis that has been pretty well supported is that a big reason that angiosperms became so successful is because insects and other arthropods sort of co-evolved with them. A lot of angiosperms are pollinated by insects. So if angiosperms do real well, insects do real well, and vice versa. So it captures a lot of arthropods before angiosperms, got doing what they are doing today. And so therefore, it captured a bunch of arthropods doing things differently than they do today.
So is that something we suspected before that they may have done differently and this confirmed it, or was this like brand new information?
Yeah, I think, we had suspected it. I don't know particularly when this. Actually, I have a tab open for it right now. I have so many tabs open. Let's see. I don't think it really says when it was found. It says the oldest reports of Lebanese amber are from 19th century accounts, so 1800s. Although basically it was people just kind of noting, man, this stuff really sucks as gems. It's yeah. Lebanese amber tends to be more opaque than some of the other ambers that we're going to talk about, so it's not great for use as gems or other kind of decoration things. So that's most of the people talking about it before it became sort of scientifically significant. But we had definitely anticipated that insects would be doing different things before, their main, co-conspirator, the angiosperms, evolved. But it's good to have a good sample from before that time.
Right.
So that is Lebanese amber. Next, we have Baltic amber. So the Baltics is sort of the northeastern area of Europe. This would be around like the north side of Germany, and in the Baltic Sea, all around like I think Lithuania, a lot of those other countries in like the northern part of Europe. This is the largest of all of the amber deposits in the world, and where over 90% of global amber comes from.
When you say the largest, do you just mean like the most number of specimens or like the most amber?
The most amber by a lot. Yeah, like I said, like 90% of amber mined in the world comes from here. Let me see if I can get a number, because I believe I did see some kind of actual number. So it was estimated that the forests that made this amber produced over 100,000 tons of amber, which is a lot.
Yeah.
That might not seem like a lot for something that is sort of a rock. Rocks are heavy, but that is a lot of amber. So
yeah, that seems quite significant.
Yeah. So this Baltic amber comes from the Middle Eocene, around 44 million years ago. We talked about the Eocene epoch during our episode about the Paleocene-Eocene thermal maximum. And during the Eocene, like I said, almost global rainforests. There was really no environments. I'm not going to say no environments besides rainforests, but pretty close. Including what is now all the way, not really known for rainforests, northern Germany, places like Finland, not really known for rainforests, to my knowledge. But this section of amber contains almost entirely insects. I think I saw like 98% of the inclusions in this amber were insects. So lots of bugs from this time. This is interesting at capturing sort of post end Cretaceous mass extinction. It's not super close to the extinction, around 20 million years afterward, but like I said, insects don't tend to preserve super well. So it's just an interesting sort of snapshot to see how they were doing 20 million years or so afterward.
Okay. And that's the largest deposit. What else do we got?
Next one that's a little closer to home, we have Dominican Amber.
Oh, okay.
Which is famous for a couple reasons. It is if you can think of one that's like a bug or other kind of arthropod in some amber that is very clear, you can just sort of hold it up to the light and see everything about it. That's Dominican Amber. Dominican Amber is well known for being very translucent and very glassy. It's also very famous for sometimes being blue.
Really?
Yeah. And I tried to look up, they talked about some of the chemical reasons for this. I didn't particularly understand it. Organic chemistry was not my strong suit. I enjoyed the class, but I did not take organic chemistry 2.
And if you didn't understand it, then, well, listeners, you're out of luck as far as this podcast is concerned.
Yeah, no, I'm absolutely not even going to try to explain anything chemistry, likely ever on this podcast, realistically. But yeah, blue amber. So at the beginning, when you were like, this is kind of, yellowish, golden, almost. I believe amber itself is even a color. For the most part, that's true. But for some reason in the Dominican, sometimes it can be blue.
Okay. Sure. Blue.
And so this one dates back to, so the Dominican's tropical-esque today. At least, certainly much more tropical than, most of the mainland United States or North America. But back at this time when it was deposited during the late Oligocene, around 25 million years ago or so, it was very tropical. And so amber itself can even give, information about environmental change or ecosystem changes just from the sap itself, even if there wasn't really any insects or anything trapped in it, which I think is really cool.
Yeah.
And so, for the last of the main four, we have
Before
Burmese
we started
Amber.
recording. Just for the record, I was told that we were going to spend quite a lot of time on Burmese Amber. So, Buckle. I assume this is going to be looking at our document here. This is kind of the main topic of what we're going to be discussing today.
Yes and no, and I really didn't intend it to be. So in my notes, this part says Burmese Amber, the sad part. So purely by coincidence, friends of the pod, Dr. Emma Dunn and soon-to-be Dr. Nasaiba Raja, appeared on an episode of another paleontology podcast called Paleocast, talking about the ethics and such of Burmese amber, because they have a paper coming out relatively soon talking about it and actually putting numbers to some of these really, really sketchy at best and illegal and human rights abuses at worst things about Burmese amber.
Mm-hmm.
So
it's gonna be super happy fun times for the rest of this episode, everybody.
So I will do my best to explain some of these things, but we will have a link to. They were on 2 episodes of Paleocast, each 45 minutes. So if you, like me, listen to things at 1.3 to 1.5 times speed, you can do that in about an hour or so. So I would highly recommend you go listen to that. We'll have a link down in the show notes, but they are much more knowledgeable about this kind of thing than I am. And obviously, like I said, they are friends of the pod, as well as Paleocast is just a very well-made podcast as well. So please go give that a listen. And it gives way more context to this than I will. But here we are. So,
all right.
Burmese Amber comes from the country of Myanmar, which has in the past been called Burma. Some people still call it Burma, and I don't understand why.
I know. I am only vaguely familiar with this, but I know like the fact that the name got changed was a sore spot for many Burmese, and so many of them chose not to go along with that name change. It's been quite a while since I looked into this, but I am aware that there were some people that were like quite upset about the fact that the name was even changed and kind of refused to go along with it.
Right. And I'm not sure what the general consensus of the people who live there is. So I will go back and forth. Just know I'm meaning the same place, whether I say Burma or Myanmar. Same place.
Yes.
So this amber comes from the late Cretaceous, which is 100-ish million years ago. And if you've seen anything about amber in the last probably close to 10 years, it's from here. Particularly because some of the fossils from Burmese amber are absolutely incredible. You have your standard stuff that a lot of the other amber has, like insects, which actually makes it a really good sort of foil to the Lebanese amber, because by this point, angiosperms have already sort of taken over. So it's cool to get a before and after for the insects and angiosperms relationship between the Lebanese amber and Burmese amber. So there's a reason why this amber is so popular with scientists. It's because it truly is, really incredible. Some of the things that it preserves. For example, feathers. There's likely dinosaur, but also definitely some bird feathers preserved in amber. Super cool.
How can we tell the difference? Like, how can we tell, oh, this is a dinosaur feather versus this is a bird? Like, how do we know the difference?
It preserves the structure so well that we can tell, and also some skin stuff, but in some cases it has preserved like an entire baby bird wing or entire bird feet. So it's like we have it's very hard to get like a full vertebrate stuck in amber because we're not tiny. Right. Although there have been whole frogs trapped in amber from Burmese amber. There was a snake embryo stuck in Burmese amber.
Wow.
A gecko foot, including like the clingy toe pads that they use to climb on walls and ceilings and stuff, preserved in Burmese
Hmm.
amber. And these are just some of the highlights that I was able to find. These, amber in general is just produces, like I said, absolutely gorgeous fossils. Burmese amber produces in my opinion, the coolest of all of these beautiful fossils. However,
Yeah.
as we've
Why the
talked about,
coolest?
I mean, just because, no reason in particular. I think it's just a really interesting time. By the late Cretaceous, birds were fully around and doing stuff. Most of the groups that we have today, frogs don't have a really great fossil record. So to have an entire preserved frog stuck in amber is great. Snakes also don't really have a great fossil record. To have
Hmm.
an embryo of all things, that just doesn't happen. So just sort of purely by happenstance, in my opinion, some of the stuff from Burmese amber is some of the coolest amber specimens.
Hmm.
However, as we've talked about, as we sort of mentioned, uh, this amber is extremely problematic. So
The amber is problematic.
yes, as well
Is
as
it
a
the
lot of
amber
other
or is it the
things,
people? Right, like the people around it.
both. So, Mike, you are a student of history.
I. This is always where I get a little bit nervous. Like, how bad am I going to get embarrassed? Okay,
I
okay,
mean, to be
go
to
ahead.
be fair, you teach U.S. history.
I teach global this year, but I'm not very good at it.
Okay. Um, so, how much do you know about the recent goings on in Burma/Myanmar?
This is we were discussing before we first started recording today. Um, I know that there is both long-standing problems in that country that are going back, decades at this point.
Mm-hmm.
And I remember there being about a year or two ago. I remember there being some sort of problem um, between. I remember like Facebook was accused of like perpetuating a genocide there
Mm-hmm.
in the last couple of years, and there was an election that like either was fraudulent or the election was fine, but the results of it were, being challenged. Um, I am aware of a number of problems there, but I have not had the chance to look into it all that deeply.
Okay. So I'm gonna go into a very insultingly brief, quick history of Burma/Myanmar over the last handful of decades. So I'm going to for sure leave a bunch of stuff out. These are just I was gonna say highlights, but that's not the right word. Uh, so the country gained
Topics of interest,
independence. Yes, the country gained its independence from England in 1948,
because of
and
course it did.
right, and uh, had a bunch of armed conflicts from different regional groups until the country was more or less united under military rule from 1962 until 1988. After lots and lots of uprisings and protests in 1988, the military held an election in 1990 where a woman from the opposition party named Aung San Suu Kyi likely would have become the leader of the country. However, the military placed her under house arrest and declared the election fraudulent. Throughout the 90s and 2000s, Myanmar basically stayed under military control despite constant clashes between the military and various armed rebel groups.
Hmm.
The military eventually sort of relented and allowed for a civilian government to form in 2008 and sort of transition to a very fragile partnership between the civilian government and the military. And that same person that was placed under house arrest was released from house arrest in 2008. And then in 2016, she was elected. I don't remember exactly what they call their leader, but the leader of the country.
Okay.
Also in 2016, a couple months after that, the genocide of the Muslim minority Rohingya people began. Like you said, I didn't have this in the notes, but it was not like for legal reasons.
Mhm.
was not caused by Facebook. It it probably wasn't helped by Facebook.
Sure.
Um, but for legal reasons was not caused by Facebook. Um, and so that sort of steady. Oh, and that also continues until today. That's still a thing that's happening. Um, and that sort of fragile coexistence between the civilian government and the military existed up until February of last year, just over a year ago, when the military declared that the recent election was invalid and placed Aung San Suu Kyi under house arrest again. And since then, in the past year, thousands of protesters and rebels have been killed by the military, and those are just the ones we know about. I think a number that I heard was a little over 10,000, and those are just the ones we know about. So um, there's a lot of really gnarly stuff going on over there right now, and there has been for the last couple of years, but especially right now. So
Yeah, not sure if we have any Burmese listeners, or people that know people there, but hearts go out to you.
yeah, absolutely. Um, but how does any of that relate to paleontology? Amber is incredibly valuable, both to science as a resource and also just as a commodity. Like I said, various peoples from all over the world, A, like to collect it because it looks pretty, but B, also it's just very culturally significant, particularly to people in China. There are lots of amber deposits in China. We didn't mention them because they aren't some of the big famous ones. Um, but people in a lot of different places in China have used it historically for traditional medicines, jewelry, pottery, things like that. Um, and Myanmar shares a border with China, and so a lot of the production of amber was controlled by the military, or at least initially was actually controlled by a separatist group up until around 2017, when the military was like, all that stuff that's making you all that money, that's ours now. Um, and basically took over the mining operations as a way to fund the military government, or the military side of the government at the time, because 2017 was still in that sort of fragile coexistence between the civilian government and the military. Um,
Right.
Around 2010 is when sort of that armed separatist group really started ramping up production. Also around that time, some of the amber deposits in China had started to become depleted and not really economic to mine anymore. So, the people in Myanmar basically were like, "Well, we have some amber to sell you," and so you'll notice a really sizable uptick in publications about fossils in amber starting in like the late 2000s into the early to mid 2010s, and then really, really going up throughout the late 2010s into 2020. Um,
Hmm.
it is currently, and was at the time, illegal to smuggle amber or fossils, either or, out of Myanmar. But they, like I said, they have a big border with China, and a lot of it is smuggled over that border to be sold in China in various marketplaces and things like that.
Hmm.
Um, the entire time, whether it was the military under the control of the mines, or the first group that was sort of in control of it, the mining conditions have never been safe. I didn't see anything specific about things like forced labor, but given the track record of the military, it would not at all surprise me. And so basically, there was a specimen published in March of 2020 that was very high profile. It made the cover of Nature magazine, or the journal Nature, probably the biggest science journal in the world. It made it on the cover, and that was a full lizard skull, a really, really cool, unique lizard skull that made a bunch of people go, that doesn't seem right. And then a bunch of people who, you know, being on the front page of Nature draws a lot of heads, or turns a lot of heads. So a
It
lot of
as it,
people,
yeah.
yeah, a lot of people who were sort of aware of some of the things going on in Myanmar at the time were like, nature, what are you doing? Like, do you not happen to look up where any of these specimens come from? And all of that sort of bubbled, especially with everybody being very frustrated in 2020 to begin with. But that led to a bunch of different, paleontology societies being like, hey, maybe we shouldn't be supporting this. So, for example, like I said, that cover or that specimen was published in Nature in March of 2020. In April of 2020, the Society of Vertebrate Paleontology, basically like the club for vertebrate paleontologists at least, basically published a very open letter proposing a moratorium on publication of any fossil specimens purchased from sources in Myanmar after June 2017, which was when the military took control of the mines. Several other places have gone further and said we will not publish anything to do with Myanmar amber anymore, because it's like, we have no idea when you got this, when this was mined. We have no idea, any of the like, even if people are like, well, science is science, who cares if a little human rights get in the way? A lot of the really important scientific information is kind of just erased when it's just sort of bought in a market like that. Knowing where things were in the ground is just as important as, what kind of animal it is.
My main question with all this, though, is that if you're suspending, scientific research on that front, is this one of those things that's designed to protest against the government and show you're not going to do it, but will actually hurt the people on the ground more often who had nothing to do with any of this, the scientists and the workers that are extracting all of this amber? Is this one of those things that could do more harm than good to a lot of the people on the ground?
I'd say if those people were being compensated properly for their work, maybe. But that, at least that is kind of known to be not the case.
Okay.
These people are paid very little considering how much this amber is worth. Like if the people, obviously it's not the military picking up a piece of amber and being like, this is worth a lot of money. They have people who, either they pay to know or they threaten to know how much these specimens will go for. And they basically, say, hey, scientist, I got this really cool thing here. How about 10 grand? And granted, I don't think, most scientists would buy things like directly from the military like that. But if it ends up at some, marketplace in China, the marketplace bought it from the military people or bought it from somebody who did, or so on, supply chains. Regardless, money is going to somebody nefarious here who is likely abusing workers to get it and, smuggling it out of the country illegally. Because like I said, there are laws there. Just because the military is the one violating them doesn't mean that there's not still laws. And this is something that Emma and Nasaiba mentioned in their conversation with the host of PaleoCast, is they did like a real deep dive into every publication involving Burmese amber that they could find. And I might be misremembering this. I only listened to it once. But I believe out of like around 200 publications that they found, I think they said one of them had proper documentation or even mentioned anything about documentation for the specimen.
That's not enough.
No. So it's like, okay, Nature, are you cool with publishing this specimen that we have no idea where it came from? That doesn't like I said, putting aside any human rights things, that just doesn't sound like good science to me.
This reminds me of the one meme I don't remember from what TV show, but it's something along the lines of like I can excuse the racism, but I draw the line at animal cruelty.
Yes, I've seen that as well
racism.
Too.
Yeah, I can excuse the human rights violations, but I draw the line at bad science. Like I think we're drawing the line at the wrong spot here, but okay, fine.
Right. So there have been many journals and things that have basically said, well, many is maybe too strong a term. There have been several journals that have said we will not publish on things. You have to have proper documentation for it that you will submit with your paper. And if it's from after 2017, we're just not going to take it. Some have been just again like a flat out, we will not accept any papers regarding Burmese Amber right now. However, there have also been a lot of people playing devil's advocate, and also a bunch of people just being like, I want to publish this, so I'm going to publish it. I want the publication, so I'm going to do it. So that's not cool. Emma and Nasaiba put it much more eloquently than that's not cool. So please go listen to that episode. Also, Dave Marshall, the host, does an excellent job. So please go listen to that episode. This is something that's really important to me. I'm directing you to another paleontology podcast that's not ours, but it's something that this is a thing that needs to be talked about. We're going to try. I haven't reached out to them or anything about this, but when that paper does come out, they said in a couple months, when that paper does come out, I would really like to have, Emma and Nasaiba and some of their other co-authors as well on the show, just to sort of talk about it in much more eloquent detail than I possibly could. So, and also
they're
go ahead.
Just if you haven't had a chance to listen to their episode, they've been guests on our show before, and both are just truly fantastic. I believe, who was it Dr. Dune that was on our 50th episode spectacular?
Both of them were.
Oh, that's right. Okay, so they were on together as well as on our sort of compilation, what does science mean to you and how'd you get into science episode. Yeah. So if you haven't had a chance and you don't know who we're talking about, you can go back and listen to those episodes. And they are fantastic.
Yeah, absolutely. And something else that they pointed out, and this is a little bit off topic for the amber side of things, but I think they said very, very few. I'm not going to say a number because I don't remember it, but easily less than 10%, probably less than 5% of all papers regarding Burmese amber included a Burmese scientist.
What percentage?
Like easily less than 5.
Okay.
Which was the whole point of our initial conversation with them. I believe that was episode 33 about decolonizing paleontology, where it's like you get stuff from a place, you don't care about the scientists who were there. You just want it kind of for yourself.
Right.
So there's a lot of that going on, particularly with Burmese amber, but just in paleontology in general. But at this point, we're digressing. So this is a very complicated topic about a really cool thing that we can learn so much about. Like I said, amber is the source of, in my opinion, some of the coolest fossils. Because not only does it preserve the bones, not only does it preserve, maybe certain chemical things about the animal or the plant, but like an entire frog. Cool. the toe pads of a gecko, where it's like, but before doing the research for this episode, if you would have asked me, hey, do you think we'll ever have gecko toe pads in the fossil record? I'd tell you no. I'm like, I would have no idea. Or when did geckos get their toe pads to climb up and down walls and things? I'd be like, I don't know. I kind of don't think we'll ever really know that. But here we are. Amber makes impossible things in paleontology possible, but comes at such a huge cost. Let alone financially, but also just in the terms of like human rights. So, we're not going to take a particular stance on this podcast, but I kind of feel like where at least I stand on this subject. So that's pretty much going to wrap it up. Amber is really, really cool. And when it's ethically sourced, is some of the coolest paleontology and paleontological specimens out there.
Yeah, don't get mad at the amber itself. Get mad at at humans, and the way humans are using or abusing, anything. But in this case, amber is what we're talking about.
Right. And also just a little bit more of a digression here as we're wrapping up. Something that I've seen people do, like a devil's advocate, or maybe it's just them being a devil, on around various parts of the internet is, would you rather that piece of amber with that precious gecko's foot just be sold off into a private collection, never to be seen again, or just not be mined at all and get lost to time, as many fossils do? And yeah yeah, absolutely. I've talked a lot about how I hate private collections. I think I've mentioned before that the very famous T-Rex specimen Stan was sold into a private collection for like over $30 million relatively recently, and that made me real mad.
As it should.
But at least to my knowledge, in that case, there were no human rights abuses. So would I rather fossils be lost to time rather than actual human beings suffer? Duh. Yep. Like,
it's not worth it.
And I don't know how anybody's playing devil's advocate with that stance, but you'd be surprised. So, anyway, we've rambled long enough about tragedies. So we will see you all next week with, hopefully, next week's, spoilers, a Mike Takes the Wheel episode. So, maybe.
Which means that neither of us know what we're talking about yet.
That is correct. So I'm hoping, fingers crossed, that Mike will maybe be a little more cheerful after this episode.
Not a whole lot to be cheerful about today. However, this has been episode 62 of I Wish You Were Dead, a podcast about things that used to be alive. My name is Mike, and that is Gavin, and we will see you all next week.